Right, so I am just giving this uh, amplifier I fixed a bit of a bake test. I didn't really go. I've not bothered filming any repair on this. It was just simple as a single blown output transistor. You know, how many blown output transistors do you need to film? It's more the same. Drivers survived all right. I kind of feel it was actually might have been a faulty transistor from the off, because there's no other destruction on the board. So I'm guessing the first time someone applied power to this, it blew the fuse, and there was a note on it saying it kept tripping the breakers. So whether they put a new fuse in it and tried it again and it did it, or if it was first time round. But the arc from a fuse is certainly, if you've got arc detection on your breaker, um, if you've got arc fault detection breaker, it will certainly should be enough to detect that, and it will trip the power out. So sort of thing, if you're putting this in an installation and you plug it in and it trips the power out, you just send it back straight away. So I'm baking it. As you can see, the heatsink is up to 54 degrees. It is getting quite toasty. I did have it hotter earlier on and this a lot hotter. And so anyway, I'm just kind of playing around with this, and you can see, so there is on here, zoom in a little bit, so there is a power gauge kind of. How well that's shown up I don't know, because I've got a lot of lighting on here, but there's a slight adjustment pot on it. So if I wanted to, look, I can see, look, I can, it's running flat. I can make it so it's barely registering, or I can make it so it'll just sit on constantly. This amp is just about maxed out. It wants to be sort of strobing away like that, really. But anyway, the reason I'm making this video is, sod's law, it's gone for a quiet bit, is the amplifier itself, because it is transformer coupled. So if we come back in here, so this is the power transformer. It's alright, it's all grounded as long as I don't touch, and the wiring is actually quite well insulated in this. This is the output transformer. It's a 100-volt line amp. So as you can see, it's not particularly big transformer. Now the amp's rated at 120 watts. 35-volt rails, push-pull arrangement. It probably gets somewhere near that. It certainly makes my dummy low toasty. However, because so there's a tertiary winding on the output transformer, comes back here. It's used as a feedback winding. You see the thin black and white wires coming off. Because it uses feedback, at the point where the output transformer goes into saturation, because there's too much drive voltage across it, or too much low current coming out of it, whichever one it is transformer theory's simple but complex. Anyway, at some point the amp overloads, or the transformer overloads, sorry, and it cannot absorb any more voltage or generate any more current, and it's seen by the amplifier through the feedback line. The amplifier tries to compensate, and the transformer just goes into saturation. You get a really nasty failure mode. The bias on the transistors goes through the roof, but there seems to be nothing on the amplifier board to stop it. So I've got a speaker up here. This amp's running that flat out. I've got a 220 ohm resistor in series with the speaker, just to limit the volume. It would fry the speaker. So now what should happen? Let's say I turn the bass up a bit, to the point being where I'm really start pushing the amp. Can you hear that? So yeah, what's basically happening there, is the amplifier, the transformer's going into saturation, the amp's trying to compensate, and then you're ending up with all manner of nasty things going on in the output stage. There's some overload node going on. There's like a time constant, mate. It's a capacitor coupling from the input to the drivers or something, because it's a MOSFET driver stage in this, and it's after overload. It's taking considerable time to recover. But I'm thinking, well, I've kind of got here, I could like this is the adjustment it's at. It's not bad, the plus 3 dB light is just sort of gently coming on. If I knock the volume back a bit, you can see it's only just occasionally flicking on. I've just been messing with it, so I could just de-adjust that out. So yeah, and when I crank it again, it'll start flipping up. So what I'm thinking is, if I take the signal that's driving this plus 3 dB light, I adjust this trimmer, I've got essentially already an output drive for a basic audio limiter. So I've got here, this is just a diode. I can't remember, I've had this kicking around for ages. I was messing about earlier on in the year. This is a diode, possibly just a red diode, one side, and a photo cell the other side. And I'll show you what happens when I apply current to that. So I've got my meter on the 20,000 ohms setting. So it's 2,200 ohm resistor, 9-volt battery, and the LED LDR light pipe kind of thing I've made. So with the LED forward voltage and what's in the battery, somewhere between 6 to 7 milliamps of current on the LED. And as soon as I put that, bit of a shaky connection because I'm just holding stuff together. So yeah, you can see, go down to the 1000 ohm setting. So about 1000 ohms, and when I remove it, I can go, look. So as you can see, actually the LDR, it's very slow recovery time on an LDR. The first thousands, like in the lower scales, it will go so quick the meter won't keep up. So yeah, but the higher ones you can sort of see the recovery time on it. So I'm thinking if I splice into the signal wiring, say put 10,000 ohm resistor or something in series with the signal wiring, and then put this LDR output parallel to 0V, and wire the driver on this, I should be able to series these LEDs up, because as far as I'm aware, it should be a constant current output on it. So I can just break the connection to the red LED, series it up with this one, because you can't parallel the LEDs, one will light and the other won't. Well, you can if they was identical LEDs, but seriesing it will be better. And so what should then happen is I can adjust that trimmer, so way before it reaches that maximum volume point, as it starts flicking the red LED on, you know, quick flicks, it'll just give a gentle limiting, and it will reduce the volume right down. And I don't think you'd ever be able to actually get it to be on to the point where it would be driving the ass off that transformer, because every time it flicks on, this photocell is going to go very low resistance, and very dim lightings, it's only going to be a few thousand ohms. But it takes time to recover again, and no matter how hard you keep trying to drive it, it's just going to keep the same thing, is going to keep repeating. So, and then you'd end up, you know, you think about, you've got a 10 ohm and a 1000 ohm resistor in series, you've got about a 9-to-1 attenuation or something. So if you needed to say this amp needs, let's just pull some stuff, not measured, let's just see it needs 2 volts to drive a circuit board to full power. Well, you then need 18 volts coming out of the driver stage to do that, and there's not enough headroom in the driver stage for that. So yeah, it's just going to be a very basic and crude audio limiter, and the response to the LDR is perfect because it'll come in quickly and it'll just gently rise back up again, and it'll just repeat. It'll just keep gently cycling. Anyone who's like trying to hear that volume control will just keep seeing a red light come on, and then the volume should drop down and come back up quickly, and not notice that if you knock the volume back, it'll stop doing that. So yeah, I'll do some wire probing and see what I can find. And interestingly enough, look, you know, temperatures up to 64 degrees on that heatsink. And that is hot. It's about as hot as it's going to get. I think that's not bad. That's not bad. So yeah, let me do some figuring out which wires I need to splice. I think I'm going to have to take this front panel off to actually get to everything, and see what I end up with and how well it actually works. So yeah, at present I've got I'm trying to move the camera around, trouble. I've got an audio transformer there giving me, so just using it to boost up the signal from a telephone. I'm just running this, it's just Deezer playing some music. Wasn't a high enough level because this is only the slave version, it doesn't have much of the inputs on it. It just has a balanced input and these 3 basic controls. So the audio transformers just upping the signal voltage, and yeah, it present basically flat out. It's sort of, you can hear, I don't know if your camera will pick it up, but you can actually hear the transformer singing to the music, and when you start overloading it, it really start, you can hear the stresses in the thing. It's the magnetostriction of the core, and some of it's going to be the windings just singing slightly as well. But yeah, see what I get. But yeah, seems to stabilise with the lid off in the mid 60s. This room's at about 18 degrees. To be honest, there's plenty of ventilation in the lid, and underneath it shouldn't get a great deal hotter with the lid actually on. But yeah, you got to, you know, if you fix something, you've got to run the ass off it just to see what happens. So yeah, let me take this front cover off and have a play around and see what I can come up with and see how well this works. It might be a complete failure, but only one way to find out, isn't there? So it's an hour later or so, and yeah, I annoyingly made a mistake when I was making it. So you want the LDR to obviously be in the audio signal going back to the amp. And I somehow, not sure how, ended up cutting into the audio feed up to the potentiometer, which is a low output feed from one of these op amps, and ended up putting the LDR then op amp side of it, so it was basically literally doing nothing. So moving the LDR to the other side of the resistor, although it's now working, I've lost some signal because I'm coming, if you follow the signal chain, I'm going op amp, resistor and potentiometer. So the resistor's always seeing the attenuation of the actual value of the track in the potentiometer, so which is a bit annoying. I've lost, you know, I have to drive the amp harder to get it to do it, but it's yeah, the basic concept's working. So you're on the tripod still, so can you see the fingers in that black bit there? That's the LDR. Look, you can see coming up on the orange wiring going into this board. If you notice, this board, it had these little like light pipes. There's a surface mount LED behind the light pipe, so this black bit sat on the board, and the light pipe was pushed into this black bit, and there was a surface mount LED behind it. So to actually get to the track, I had to destroy that bit. I couldn't get it out, it was glued in, but it's no problem because I've just put a 3mm LED in here, which is just slightly recessed behind the front panel here. So yeah, what happens if I crank it up? So I don't know how well it'll come out on the camera because the camera's going to be trying, but you'll just see that starting to flick, and I can you hear how bad? I mean, the LDR is going to sound really distorted and bad. It's as a basic limiter, they're very high in distortion. You'd normally have additional distortion cancelling circuitry if you was going to try and use an LDR as a compressor. This is just like a basic limiter. So if I actually turn the volume down, you notice how there's no difference in volume change there. I'm just still getting that to flick. All that happened was the distortion went down. So I just crank it up and it just gets more distorted. You can see it's just kicking in and it's saving it. I'm not getting the problem I had before. And if I actually start trying to tweak, so this obviously this potentiometer, all this is just sets the level that this gauge works at. If I actually start backing this off and you listen, now we're back to that point of doing that thing, but you can hear it got louder if I just crank it up again. So I'm just running on the compressor there, basically the simple limiter. So that's it cranked all the way off. I'll start to come up, I'm just going to get the red LED to flick on, which is also in series with the LED in the light pipe, and if I turn it up more, it actually gets quieter. Not touching the volume control, that's all being done. So yeah, it's now just cycling. You can see it's just basically as this red LED at the top flashes, just for a fraction of a second is all it comes on for. If I zoom in on it, you can see it's just flickers because oh, kick the camera. Behave. So the second it comes on, the LDR on my light pipe's instantly going to end up seeing the light from the LED in it, and it's going to attenuate the signal. So as sods laws have it, just as I try and explain it, I end up on a quiet patch. Come on. Let me pause a second. So it's probably a better view. So you can see, look, the 0 dB light is almost constantly on, yet the plus 3 dB light is lighting for a second and just going out, because the second that lights, the LED in the LDR light pipe is lighting up, knocking the signal back then. So of course this goes out, the LDR is starting to recover, and as soon as it starts recovering, this will happen. So it won't just sit in equilibrium because there's a time constant there. But as I say, if I back off this adjustment here, you can see, I don't know whether you won't really pick up, but you can see now I'm just sort of flicking. I think I'm just at the cusp of it coming on there. So yeah, and if I try and crank the bass up, instead of it going into that distortion mode thing, you see it's just limiting, it's acting as a compressor. As yeah, I just need to, it's just doing so I can now use this to actually set where I want it. And if I just tweak it a bit, there we go. Yeah, so there we are, look at that. It's just running on that. So there we go. So basically by me tweaking it, I'm making this gauge come on earlier. And before it gets to the point where it can clip the ass off the amplifier on low frequencies, it's coming in and it's sort of limiting it. It sounds absolutely horrible. If I back the volume off, so I've got the bass crank right up there, actually turn that down. That's the way you want it. It works. Perfect. So yeah, a random little experiment works a treat. Like I said, I just wish I hadn't wired it into the wrong bloody side of the volume control pot. I actually like cut the track on the board and everything and wired it into the wrong bloody side, but that's sod's law in it. So yeah, no doubt YouTube will try and give me loads of copyright strikes for all the music, but that's just YouTube for you, isn't it? How well does that work? So yeah, anyway, that was it, just a random, can I make a basic limiter using the VU meter supplied as part of the amplifier? And the answer is yes, you can, with nothing more than a small cheap LDR, light dependent resistor, and a cheap LED and some heat shrink tubing. Yeah, I've literally, because this is a constant current driver in this chip, I've just series the LEDs up, no extra resistors, nothing, and job done. So yeah, voila, send that out now knowing that it's a little bit more robust than it used to be when it was originally built. But yeah, as always, thanks for watching and catch you next time.